All right. Cool. So welcome. This is the NAPI talk. So how many of you are aware of NAPI? Wow, that's good. That's good. Are you guys, any of you, show of hands, have native modules that you maintain? Sweet. All right. So we're going to talk about today is how NAPI is going to help improve the experience, developer experience with Node.js, and more specifically around how it is going to improve the deployment story of your Node.js apps. So my name is Arunesh Chandra. I'm a senior program manager on Microsoft Edge team. I've been working on the Node community for several projects like NAPI, the Node Chakra Core project, and some developer diagnostic innovations like the time travel debugging. I'll be around the conference for a couple of days, so find me if you have any questions at the Microsoft booth, or these are my contact info if you want to reach out to me later on. And
hi, I'm Michael Dawson. I'm IBM's community lead for Node.js. So if you've been involved in the project, you'll see that I'm active in a lot of the working groups, obviously in the NAPI team, as well as being on the technical steering committee and on the community committee. I also get to work with a lot of great teams within IBM where we've done really interesting things like port V8 to our platforms, PowerPC and S390, as well as work on some of the larger projects like Loopback 4, Cloud Native JS.io, and so forth that you saw Chris talk about in the keynote this morning. So anyway, back to Arunesh.
And just a reminder that there will be a, what is it called?
There's a session in the community corner just outside where we're going to have the larger NAPI team present. And so if you have questions, want to get involved, we'd love to talk with you. So, come on out and talk to the larger group out there afterwards.
Right. All right, so let's start with some basic understanding that we all can agree about the relationship of Node.js with its NPM module ecosystem. So first, the vast module ecosystem makes Node.js more powerful. So we all can agree that the module ecosystem we find value in that, and that is generating is a source of power, generating powerful impact on the Node.js platform. Node.js growth depends on the stability of this ecosystem. So more reliable and stable this ecosystem is, the more Node.js developers are going to be relying on this platform, and it is going to help fuel the growth of this amazing platform that we all know and love. And the third, because the previous two, if we agree on that, we need to ensure that this module ecosystem that we all love and depend on has to be preserved and strengthened going forward. So if we all agree with this, today, this module ecosystem is very fragile, and it needs help. So what do I mean by that? We all are aware of this particular user. This error that you see. Module was not compiled against. This module was compiled against a different Node.js version. I'm sure it would be a familiar message for a lot of people. And what the problem is that we have accepted that this is normal. We know how to work around it. We either change the Node.js version that we are running on, or find the latest version of the module and match it together, and then it works. This is now, this is basically, this happens quite a lot. A few weeks ago, we saw an instance where deprecated V8 methods actually caused modules to break in the latest Node version, and the Sirgim test suite that detects these kind of breakage had failing at least 10 failing modules. And these kind of breaks are actually causing friction in Node.js upgrades in mission-critical deployments. So this is not how a mature enterprise-ready platform is supposed to work. We shouldn't take these kind of failures as an accepted fact of your programming life. So there got to be a better way. I mean, there has to be a better way to kind of not create such an impact on the entire ecosystem with every node release. So imagine, all the modules are living peacefully without breaking. And it's easier, if you imagine. If you are an app developer with Node, imagine that upgrading Node was easy. It was easy to swap back and forth between different versions of Node. There were more high-performance native modules available for you to work with. And all these modules were portable across different Node versions. Binaries were compatible. And there are several different Node flavors coming up in the market as well. Like Node Chakra Core is one, Spider Node. There's another one which is worked on iOS with JS Core engine. So these different flavors of Node will not work with the existing way the native modules are working today. So imagine that you're able to take your app, take any Node version or flavor, and just drop it in, and it works. Imagine if you are a module maintainer yourself. Imagine that there's no code update required or no new binaries you have to create to support a new Node version. It's easier to write native modules. The APIs that are available for writing native modules are safe and well-defined and well-documented. And your modules will run on different flavors. So these are the things you should expect from a mature enterprise-ready platform. And we are not there yet. So we're going to be covering how an API is going to bring about this dream and provide some history and context, and also how you can help. So what is an API? An API is a stable Node API layer for native modules that provides ABI compatibility guarantees across different versions of Node and flavors. An API enables native modules to just work across these different versions without the need of recompilation. That's the key word here. You don't need to have this recompilation step that goes on today. This has been worked on by a variety of contributors, from individual contributors from the community, and also had people working from these Node.js Foundation member companies as well. So this has a very broad-based effort has been put in for a couple of years now to bring this to life. So some quick context here, where the NAPI value lies. So a long time ago, JavaScript was tied to the browsers, but somewhere along the way, it escaped the browser sandbox and landed on the server. And Node.js revolutionized the use of JavaScript on the server, and to meet these new demands of server application, it was important for Node.js developers to take advantage of the native capabilities from the platform. So hence the use of native add-on modules. It allowed developers to extend the capabilities of Node.js by building native libraries and exposing them to JavaScript. So native add-on use cases, here's some of the use cases. Accessing native APIs on the platform, available via JavaScript. Derive better performance for compute-bound code using C++. And occasionally, you see that there are some legacy C++ code available already, that how to bring it into your JavaScript app. So these are some of the use cases where native add-ons are helpful. And there are a whole bunch of these native Agile modules available today. Here's some of them. But sometimes developers take direct dependency on these native modules, and sometimes they don't even know, and it comes in as an indirect dependency. But it all kind of impacts your application, whether or not you have taken direct dependency on it or not. And by some estimate, there's 30% of the entire module ecosystem depends on native modules. So native modules, has a very important role to play in our ecosystem, and we need to take care of it. So before there was NAPI, there was no ABI stable layer in Node. So native modules, used to bind directly to the JavaScript engine. And they would take dependency on the version of the JavaScript engine inside the Node release. And this would, because of that direct dependency, it would cause those modules to break on every new release of the Node version. And negatively impacting roughly 30% of the ecosystem, which is not something a mature platform should be doing. So to deal with this fallout, where the modules used to break, every new Node release would require module maintainers to update their modules to support new Node versions. Every time a new Node release comes out, native module maintainers will have to change some code to support the new release. And module consumers, the app developer, have to wait for that event to happen. That you either look for wait for the module updates to happen, or if your modules have depend on NAND, then you have to recompile your NAND modules to be able to take advantage of the new Node release. Talking about NAND, NAND was the first attempt to solve this problem. But it didn't go that far. It's available since Node 0.8. It has done a pretty good job so far. But NAND can only provide so much isolation. It doesn't certainly address the deployment issue of having to recompile your modules at deploy time. So we needed a new approach. And the NAPI is the new approach. It introduces an ABI stable layer, as you can see in this graph here, or chart. This introduces an ABI stable layer. NAPI modules, or the native modules that depend on these ABI stable layer, are guaranteed to work across different versions. And the use of these modules, the NAPI modules, will improve the experience of the developers who are maintaining these modules and for the users who are using it. So if we imagine this world that all the native modules are NAPI-based, then the module maintainers don't have to update their modules to support new Node.js versions. And the consumers of those modules, they don't have to recompile their NAPI modules, or they don't have to wait around for the module owners to bring out the latest support for their new Node versions. So this is certainly one way of making sure that our module ecosystem continues to be robust and brings out this mature paradigm in Node.js app development and making it enterprise ready. So with that, I'll hand over to Michael to take it from here.
Great. I'm going to take over from Arunesh. Hopefully he's painted a picture of where we're at and helped you imagine a world where it could be better. And to start out, to sort of reinforce that, I'm going to start by taking you through a quick demo which shows the experience upgrading from version 8 to version 10. We all know that version 10 is going LTS in the next few weeks. And what's my experience going to be like when I go to upgrade my application? We have a demo application. You can actually go to the repo that I have there, and that's one where you can check it out, and you actually can run it yourself, showing that you can upgrade and change between different versions of Node.js and have the application continue to run when you're using an API, and even switch between different flavors of Node.js. As Arunesh mentioned, there are things like the Chakra core-based version, and you can compile your module once and then run with any of those different versions. This demo is a simple database application that depends on a single native module called Level Down. I've pre-compiled it, so I pre-installed it using version 8, sort of as my base, because I'm doing an 8 to 10 upgrade. And I'll show you using NVM to basically switch between the different versions, and we'll see what kind of experience we get. So we start out, and you can see I'm using NVM to switch the version to version 8. I'm then going to run Node to start up that application, and you can see that it actually starts up and runs just fine. I'm not actually going to go to the UI and add database entries or anything like that, because that's not important to see. I'll then kill that, start out, and I'm using NVM to switch over to Node 10. And unfortunately, what you see is we see the error that Arunesh showed earlier, where it doesn't even start up. So now I'm going to have to go off. I'm going to have to either at least recompile my application, make sure I have compilers and all of that installed, and so it's really not a great experience. Instead, with NAPI, I'm going to switch back to version 8 and start up the application again, because that's my baseline where I'm starting from. We see the application starts up just fine. Once that's up and running, I'm going to kill that, and I'll switch over to version 10. And in this case, we're using a version of Level Down that we compiled using NAPI, and you can see the application just starts up and runs just perfectly. So this really shows the experience you can expect when you're using modules that we have today versus modules that we hope to see mostly in the future when you're using NAPI. We upgrade between version 8 and 10, everything just continues to run just like our native JavaScript modules. The other nice thing is if I have this in production and I discover that for some reason I want to go back to version 8, I can just switch back to version 8 of Node, and it continues to run. So it gives me the flexibility of being able to switch back and forth quite easily, which is really a good thing. So hopefully you're excited about NAPI, you want to be using it, and the question is, well, first of all, where can I use NAPI? Well, as of today, you can use it in all the different LTS versions. It's stable in version 10 and version 8. It's still technically experimental in 6.x, but it's a documentation-only experimental. There won't be any warnings or anything else when you actually start up your application. So for all effective purposes, you can use it today across the different release lines. And for version 6, when we did the backport, we had to make a few extra changes, and that's why we marked it as experimental. Given that its lifespan is only till next April, it's likely to stay that way, although if we had a lot of feedback saying that this was holding people back from adopting it, we might be able to actually change that and make it stable in 6.x as well. So how do I use NAPI? Well, really, there's two different ways you can use it. The first one is C. So NAPI is a C-based API. We do that because that helps us maintain the API stability. It's built into Node Core. It's part of the standard API docs. And so basically, you would just include node_api.h, and you can compile against the methods that are provided there. And I have some slides later on to show what they look like and give you a flavor of what the API is like. The thing is, though, that we know that a lot of people develop in C++, and for a lot of people that actually can be much more effective. You can have more compact code. So if you prefer to do that, another project which is not technically part of NAPI, but which we've been working under the Node.js organization is Node Add-on API. And basically what that provides is a set of C++ inline wrappers around NAPI, so you can run in C++, write in C++ and get the advantages of using C++ itself. Now, when you use it, what you see is you write what's on the top. So basically, I'm creating an object, and I'm assigning a property to the object. I've got 2 lines. But in your actual code that you compile, the inline C++ expands to the code we see below, which makes the NAPI C-level call. So, calling nappy create object, nappy create string UTF. So in fact, when you're using Node Add-on API, you really just are using the C APIs. There's no extra dependencies, nothing else to link in. You get all the benefits of using NAPI, the API stability, because you really are just writing the same code in a more concise and more compact manner. So that's one of the key things about Node add-on API is that it's really just a wrapper for writing your code more effectively. In terms of the API shape itself, it's basically a collection of C APIs. As I said, we use C because that's easier to maintain stability. You'll notice that every function returns a nappy status. So basically, this is a standard pattern that we use. If you get a nappy OK, that means what you requested happened, everything was fine, you can just move on. If you get something other than nappy OK, that could mean one of two things. There's a particular status code which is nappy exception, and that tells you that an exception happened. So for example, maybe you made a callback to JavaScript, it threw an exception that wasn't caught. It's telling you that, well, there's an exception pending, and once you return from your native code, that exception will percolate up through the stack to be caught or to be an unhandled exception and terminate the process. Generally, when that happens, it means something's gone on that you probably don't want to recover from. There are methods in the API like nappy get and clear last exception, so you can actually handle that exception if you want to. But for the most part, in the code patterns, you'll see that happened. You'll simply do whatever cleanup you can and return so the exception gets thrown normally. The other thing you'll see in the APIs is that, otherwise you can also, in terms of nappy status, you can also get something that tells you, for example, you passed the wrong parameters to the C call or something else went wrong at the C level. In that case, there might also be an exception pending, so you need to check that as an extra check in those cases. The other common pattern is that the first parameter is always a nappy m. That's an opaque token that you need to pass into all the calls. It allows us to sort of maintain state behind the scenes for nappy itself. And the other thing you notice is because we've used the return code, all return values are passed back to you through an in-out type pointer like we show for the result here. To go through and get all the documentation, it's all, like I said, it's part of the standard NEP or part of the standard Node documentation. And you can also just look at the Node_API for the functions themselves. There's a great set of examples. So if you go to the Node.js project, again on add-on examples, Node add-on examples, there's a bunch of examples that show you how to do typical things that you want to do in your add-on in a bunch of the different approaches. So basically, there'll be examples for 10, 12, possibly for NAN, and then for NAPI and Node add-on API. Of course, when we add new examples, we're focusing more on NAPI and Node add-on API. But for a number of them, you can sort of compare, and if you're moving from NAN, for example, you can actually look at the example and see what was done. This is a simple example here where we can just see some of the code. It's 3 callbacks, which is like, how do I make a callback from my native code? The actual code that does that's on the next page. Couldn't fit all into the single page. The sort of key thing here is that you have a C function. It has a particular signature, which is basically you have your env and your callback info. And then you have an initialize function where you basically can create a sort of JavaScript object, which is your function, and you pass a pointer to your C function. And then you return that, and you return that as your export, so that when you require that method, you get that function, you can call the method. And if you've been writing modules, you'll see that we have nappy module as opposed to node modules as the way you set the entry point into the native module itself. This shows the example itself. Again, the C API is fairly straightforward. We're doing very basic things like, we've got this callback info, so I want to get the arguments from the callback info. So I start by getting, nappy get callback info. I get the arguments. The first argument I know is the callback that I want to invoke. And then I can call, nappy create UTF-8 string to get a string, which I'm going to pass to that callback, which I call in the last part. But all, should be fairly straightforward when you take a look at it. We mentioned Node add-on API. So this is the same example, but written using the C++ wrapper. And we've got the NAN version and the Node add-on API version. The key message here is that, if you're using NAN, it should not be that big a change. They look fairly similar. We still have like our Node API module versus Node module. We still have an initialization method. And if anything, the calls to actually create the objects, get access to the parameters and all that are a bit more concise than NAN. We didn't make it an exact copy because we wanted to make it like sort of the best development experience we could as opposed to just taking exactly what was there. It needs to be a bit different. You have to do some work to port from NAN anyway. To help make a conversion, because we know a lot of modules will start out in NAN, is we have a conversion script. Once you've checked out Node add-on API, you can use that conversion script. You just run it, and it will try and convert as much as it can from NAND to Node add-on API. I'd say it probably does about 80%, so you still have some work to do, but it's a good start. So what are people saying about it? Well, there's really two kind of things that we hear as the main messages when people are talking, that we hear people talking about NAPI, both which I think are really great. The first one are like, people are saying, hey, this is really important. This is the kind of thing you expect to see in a mature language, and that, we wish that we had this kind of API before. People seem quite positive on the shape, the fact that, it's going to be an API they can write to across versions, and just that, hey, this is a sign of growth for the project and for Node itself, that we're starting to get to see some of these more key components. The other thing, which is not something we necessarily set as initial goal, but is really good, is that people are also saying that they like the shape enough that it's actually making their life easier in terms of developing their add-on modules. It's like I went to write a new module, and boy, I really found it was easy to use Node add-on API. It was intuitive, it was clear, and it was even easier than we'd written in NAN and with V8 and all that before. So I think it's a really good message that people are saying it's easy to use the APIs and the tools that are being provided, and easier than it was able to do that before. This is just a concrete example of this. LL Node is another project within the Node project, and there's other talks today. I'd suggest you go see them, because diagnostics are also very important. But this is an example where Joey, who has been working on it, was pointing out that the code became much simpler after moving on to use NAPI. So I think that's the second benefit we're seeing and people talking about, which is really good. The other thing we're seeing is that because you can potentially write a single binary and have that binary run across different versions, people are going to start doing things that they couldn't do before. Logging is an example where there's lots and lots of loggers, but almost none of those loggers are going to use native code because of the complexity that would be required in managing the different binaries across the versions. And this is a logger that somebody wrote, which leverages NAPI to be like 4 to 7 times faster. And it can do that because it's using native code. And it was really only practical because of the advantages of not having to recompile for all the different versions. So to sort of end up with, hopefully you're really excited, understand the problem, want to get involved. So how can you help? So if you're an application developer, the first thing you can do to move your life closer to that experience where we just saw it work when we upgraded from 8 to 10 is to look at the modules that you're using. If you're selecting a new module, look for ones which have an API. We've been working on badges so that module owners can tag their modules with a tag that says, yeah, I'm supporting an API. We've also created a script. So again, in the Node add-on API project, if you check that out, there's a script and some documentation that goes along with that will help you identify all the modules in your project which aren't using an API and which potentially you're going to need to upgrade or recompile when you move to a different version. And so if you have a number of those, comment that make comments and talk to the module maintainers to see what their plans are for an API. Potentially file an issue asking for NAPI support at mentioning our team so that we might be able to help with certain key modules. And even if you have one which you've used, there's been quite a few people who've actually said, well, I'm going to port my favorite module so that I can contribute back to the module itself and make my life easier as well. So consider porting a module. If you're a module maintainer, obviously the first thing is to port your module to NAPI. We understand, though, that people are busy. Not everybody's going to be able to do that. So the next step is to basically to do things like reviewing the documentation, provide feedback. We can always improve on that front. And by helping out with the documentation, you'll increase the scope of people who can help out on that front. And then finally, if people come and try and help port your modules, be receptive, help to review those, and see if you can figure out if you can land those. Again, so that we can all work together towards that sort of goal of not having to recompile on the upgrades. And then finally, if you're really excited, we have an NAPI team meeting every week where we prioritize the different work that we're doing. We talk about the progress we're making. Like, for example, we have a fairly good focus now on, or we had a fairly good focus on documentation. We've now covered all the APIs in Node add-on API, and we're working on the code coverage. So come come to the meeting. It's open to anybody who wants to get involved and help out, so we'd really like to see you there. And finally, we'll just leave you with a few useful links. These are links to the documentation, how to get involved. There's some generators for generating sample projects. So, those are some good places to get started if you're interested. And then finally, I'll just say we also have in the community corridor outside afterwards, we're going to have a number of people from the community, from the API team, including Nick and Gabriel who are here, and I think Jim as well. So a number of the people. And what I'd say is if you're interested, come on out. We had a similar talk last year, and we got a number of new contributors who've been some of our major contributors over the last year. So really, if you have any interest, please come out. We'd love to see you there. So thank you very much.
Thank you.
And we're really glad you came out to listen to us today.